right, welcome to your first Algebra 2 video that you get to go home, be relaxed, but be learning at the same time. So you should have your notes out, you should be ready to write down. You might even want to be ready to pause it just in case you need to stop and get something else written down. Okay, let's go. So our lesson today is 1.1. We're going to look at applying properties of real numbers. But that might make you say, what is a real number? Well, pretty much every number you've worked with to this point is a real number. There's a group of numbers we haven't talked about yet. They're imaginary, and we'll get to those probably second semester. So under the category of real numbers, a number can be rational or irrational. A rational number can be written as a ratio, or in other words, as a fraction. Okay, so you could say things like 3/2 are rational numbers, but so is -5, because we can write it as -5/1. Okay, 2/3 is a fraction, all right? So all of those are rational numbers. It can be positive or negative, it doesn't matter. Irrational means that you can't write it as a fraction. In other words, there is no pattern in the decimal part. So maybe you've heard of pi, 3.14159 blah, 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 and it just keeps going. You might have seen things like square root of 3. If you put that in your calculator, it would say 1.71 blah, 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 no pattern. Okay. Here's a question for you. Square root of 9. Square root of 9. It's got the square root, but can you take the square root of 9? Yes, because 3 times 3 is 9. So square root of 9 would also be rational. Okay? Integers. Integer is a subset or part of the rational numbers. What we can say are positives and negatives. But if you notice, there's no fraction part. There's no 0.2 or 0.353535. An integer are kind of just those numbers without all the stuff behind them. Whole numbers are things like 0, 1, 2, 3, 4, and so on. And you might say, well, what do integers have that whole numbers don't have? I hope you just answered it in your head. The negative numbers, okay? So those are the real numbers. And why we like to make sure you're aware of all these is all of these numbers appear on a number line. So we're going to come over here and we're going to do our next example. And what I'm going to ask you to do is graph these 3 numbers on a number line. Well, when I have you do this in your homework or on a quiz or for a test, I want you to draw out a line. I want you to show me where 0 is. And then I want you to give me little tick marks or dashes representing, what are these whole numbers without anything? You're right, those are integers. So whether you write 1, 2, 3, 4, -1, -2, -3, -4, or just put the tick marks, I don't care which, I can find it, but I need to be able to see the tick marks, okay? So, where are we going to graph 2? Well, 2 is right here. I'm going to write above it, 2. -7/2. Some of you might think, well, we should keep going because we got to get down to -7, but it's divided by 2. You might want to use your calculator or your brain to come up with -3.5. Where is -3.5? It's right in between here, right in the middle. And then I would want you to label it with what the starting number was, okay? Square root of 5. Well, I can't even figure that out. So that's definitely a calculator one. I go to my calculator and I get 2.23 and so on. So just a little bit bigger than the 2. And I'm going to write square root of 5 so you can find it. Remember that as the numbers go to the left, they're getting smaller, so you're even more negative. And as you go to the right, they're getting bigger, so then the numbers themselves get bigger. Okay? All right. The cool thing about real numbers is they have some properties that we have to know. One of them is closure. And what that says is if we take two real numbers, A, B, and we're going to say they're real numbers, if we add them together, our answer is still a real number. It doesn't somehow change to something else. If we multiply them together, same thing, still a real number, okay? Commutative, if you think about your commute, that means from home to school and school back to home. If it's commutative for addition, you can do it in any order, okay? If it's multiplication, A times B is the same thing as B times A, all right? Associative. Associative means who you hang out with, who you associate with. So maybe A plus B plus C. Well, it doesn't matter. You could add the B and the C first and then add the A. It doesn't matter who you associate with, you're going to get the same answer. Same thing for multiplication. You can do A times B and then multiply by C. Or you can do B times C and then multiply by A. Either way, you get the same answer. Identity is a little different. For identity for inverse, the identity for addition, what number, sorry, that's pretty obnoxious, isn't it? What number can you add to A so that it stays A? Well, that's 0. In multiplication, what number can I multiply by and it stays the same? If I multiply by 0, it always becomes 0.
A square.
Have you come up with it? It should be 1, okay? Inverse for addition, the inverse of A is negative A. That goes back to that question that was on your activity. And the multiplicative inverse is 1 over A. Because notice, if I add A and negative A, I get the identity 0. If I multiply A times 1 over A, I get 1. That's why it's called the inverse. The last property isn't really addition or multiplication. It's called distributive. A lot of you know this one. If you see a number out in front of a set of parentheses, it means you're going to multiply each part that's in the parenthesis by what's out front, okay? So I am going to just, we're gonna try some examples of this. And I'm gonna say x plus 3 equals 3 plus x. Which one is that? Closure, commutative, associative, identity, inverse, or distributive? Hopefully you can pick out, oh yeah, that's this one, commutative for addition. We're going to do one more. If I've got 2x plus 7 equals x plus 7 times 2. What is that one? Well, what's going on? They look exactly the same. They're switched in the order. Oh yeah, that's commutative. If I had written this and then told you 2x plus 14, that would be distributive. Okay, you guys good with that? All right, let's move to the last part. The last part is unit analysis. You might have done some of this in chemistry, or maybe a little bit in Algebra 1. So we're going to go a little slower on this. I've got 2 things to say to you. Let your units be your guide, and you always want to cancel out units, okay? So, let's start with the first one. You work 8 hours, and you earn $120. What is your rate? So the rate is gonna be how much money you get per hour, right? So which label is up top? The dollars or the hours? Well, the dollars are. So what number goes with that? 120. What unit's on the bottom? Hours. Didn't I see hours? Oh yeah, right here. So 8 goes on the bottom. And when I divide this, 12 divided by 8 is $15 per hour. That's my earning rate. Okay? Let's go on to this one. You buy 8 gallons of gas at $2.60. Oh, thank heavens it's not 200. $2.60 per gallon. Well, I'm going to start out with this one. I've got 8 gallons, and I want to get rid of gallons. So where would I put it? Up top or down bottom? Oh, well, if I put it on bottom, I can kind of cancel them out, right? So we've got gallons somewhere else. Ooh, and here's the money per gallon. Let's see. Money per gallon, yeah. And that would leave me with my cost, or just the dollars. So last thing, does the 260 go up top with the money or down with the gallons? Hopefully you're thinking, well, that's $2.60 for each gallon. And now, anything that's up top we can multiply by. So we get 8 times 2.60. And the bottom, all there is a 1. And if I do 8 times $2.60, I think I get $20.80. Okay? And you're done with that one. All right, this last one, it's kind of a big deal. You want to you are going 90 kilometers per hour. But unless you're different from most Americans, you have no idea what that is in miles per hour. But I do want to see minutes per second. So let's see. 90 kilometers for every 1 hour. Okay? I don't want kilometers, do I? So where should I put that to get rid of it? Well, let's see. It's up top. I want it to cancel out. Oh, down bottom. Now, can I change kilometers into meters? Well, yeah, because I know there's 1,000 meters in every 1 kilometer. Okay, so far? Now, I've got hours in the bottom, but I don't want hours, do I? Where should I put the hours? It's on the bottom. Where should I put it over here to get rid of it? Already on the bottom, do the other one. Ooh, put it up top. And let's see, I need to get hours to seconds, but I don't know how many seconds are in an hour. I do know how many minutes are in 1 hour. So let's see, kilometers is gone, hours is gone. So now I've got meters over minutes. Is that what I want? Oh, I don't think so. So minutes is on the bottom. I want to get rid of it. Where does it go? Up top. And can I change minutes into seconds? Yes, that I can do. So now I got to fill in some numbers. I know in 1 hour there's 60 minutes, and in 1 minute there's 60 seconds. So I'm going to multiply all the things up top, 90 times 1,000 times 1 times 1, and that gives me this number. On the bottom, I've got 1 times 1 times 60 times 60, and that is 3,600, or 3,600, and if I divide, I get 25, and that is meters per second. That's a pretty long problem, but hopefully you can see how you can break it down. I'll see you in class and we'll practice all these concepts. Bye.